Hey, good afternoon, everyone. It's so great to be here. I'm Jerry from Block. I work on iOS builds. Before we get started, I want to say thank you so much to Google for hosting the conference, having it down here. It's a beautiful city, and it's so great to see you all. Cool. So today, we're going to be talking about going beyond Bazel, extending Skyframe. But first, why would you want to do this? So basically, Bazel has a great extension model. You can add rules which create actions, and you can do all kinds of stuff in Bazel. You can have aspects. There's a category of functionality that you might want to do that you can't actually do with these paradigms. And so that's what we're going to cover today. Finally, we're going to wrap up with a program that I created that will allow you to inject new functionality into Bazel and cover some of the APIs that exist internally to do so. And I started looking at this as a rules author where I was like, well, these rules can do all these things in Bazel today, but I might actually want to call this new functionality that I'm adding into Bazel. So that's kind of why I was looking at this mechanism. So yeah, today in Bazel, you can specify your build with build files, and build files generally call into rules that you create or macros which generate the actions, and then those are typically implemented as a command line. And a person that's extending Bazel is, in the form of rules, is generally going to be implementing rules that do the custom functionality. For people who have looked at some of the C++ code and some of the Java code, you might have found that to make Java and C++ compile at scale effectively, the things that you can do in Starlark, you can't do inside of, or you wouldn't able to be getting it so effective with what Starlark does. So basically, Starlark calls into the Java code that makes this stuff tick. So yeah, overall, what I found using Bazel is that Starlark was one of the things that really drew me to it. The idea that I would give developers a language that has guardrails. It's not Turing complete. It's going to be safe. It's going to evaluate. I think this is what makes Bazel great, and this is actually what allowed the ecosystem to flourish and all the amazing rules out there. And I think that in general, the ideas in Starlark are great, and I think it's a good idea to keep it as it is. However, the things that make Starlark great are also the things that limit it from doing the optimizations that you need to make C++ and Java tick at scale. So basically today, what you can do is that if your ideas don't fit into Starlark and you can't model your ideas in the form of a custom rule, what you can do is you can hard fork Bazel and pretty much do whatever you want. The problem with forking is that it doesn't extend well. So if I create a fork of Bazel as a rules author, you're not going to be able to use my fork unless you build and compile Bazel. That's obviously not a great situation to be in. So yeah, these are some of the things that I've read over the years of people wanting to do. This slide contains some ideas of things that I personally wanted to do that I couldn't do with Starlark. These are all great ideas. I think the big ones that stick out for me here are some of the ideas about how C++ and Java is optimized, but then applying that at higher levels to other programming languages and doing things that you can't do, like reading source code and then extracting information from the source code into the build graph and basically optimizing it based on that. So yeah, beyond Bazel. We could take all the things that I just put on the last slide, distill those down into common APIs, and then add them into Starlark, and then people would be able to do those things. And that's basically what has been going on in the last few years that Bazel has been open sourced. But you wouldn't be able to do like new things beyond that. You'd still be limited. So inside of Bazel today, there's this kind of building block of functionality, which is called a Blaze module. Not a BZL mod or a Bazel module. But basically what happens is all the Java code is kind of organized in these Blaze modules, and then at startup time, Bazel kind of puts all those modules into this pseudo main function, and then it spins up all the rules. And Blaze modules can interact with each other. There's the semantics of them are quite granola. So yeah, from a rules author perspective today, how do you actually deal with this Java code? Like how do you actually call the C++ functionality? What happens internally is that through some abstractions like type annotations in Java, it will effectively allow the Java code to be bound into Starlark. So when you call methods in Starlark, or like functions like cccommon, those are actually just calling into the Java code that does all the logic. And there's a lot of nice abstractions to do this over the years, and you can imagine all the different functionalities that are added into Bazel. So keep this in mind for the next slide. So what if we could take all of the great ideas about how Bazel is built internally, the idea that you would have this Java code that implements all of the core functionality, and you just call that with Starlark. That's exactly what Bazel Inject is. It is a very small layer that will allow you to take a jar file and then load it into the Bazel server process. And this was actually, I kind of like looked at this problem and was like, well, I want to add new functionality specifically for some iOS Swift compiling stuff, and it wasn't possible to do it in Starlark. So I just took everything that was done in Bazel today, making my higher level ideas and rules in Java, and then just calling them with Starlark. So there wasn't really a change. Like all the logic still is kind of like living in Starlark, but then it calls into my functionality. What happens is that when Bazel starts up, the command line program that you interface with is actually this C++ binary, and that binary calls into the JVM with a jar file. What Bazel Inject does is it takes control of the entry point in the jar file and replaces it with a new entry point that allows it to govern all the Bazel modules and do all kinds of stuff. This is effectively throwing out a lot of the reproducible and guarantees that you might come to expect, but it gives you the ultimate power to extend Bazel. So some of the other trade-offs that that might have came to your mind, if you're familiar with this code, is that there's really no Java API to do this. The Java code isn't organized in such a way that Starlark is, where there's like less touch points. The Java code has many fast-moving parts to it. So from a versioning perspective, these modules are a little bit more specific to each Bazel release. And I'm really excited about some of the announcements around Starlarkification, which was announced earlier today. And I think that like some of those ideas can actually be combined with some of the ideas here, and things like new Starlark idioms that will allow us to do more things and more robust kind of operations from Starlark is one way to get around a lot of these problems that I've discussed. And finally, like the idea that you would actually write rules in another programming language for the build system. When I was looking at this, taking a step back, it almost seemed like, hey, Starlark is a great language that allows us to like write these like reproducible rules. It has these guarantees around it. It's not Turing complete. What if you could, I don't know, have a different API in Java or Kotlin? So I think there's basically a lot of ways to improve the idea of adding in jar files into Bazel. But the gist is that you can basically take a jar file, put it into Bazel, and add all kinds of different optimizations. Bazel Inject is on GitHub if you're interested to check it out. It's a quick hack to do some of these higher level optimizations. But thank you so much for everyone who came out to BazelCon. It's been great.